dynasty, which had an idea of determinant by solving system of linear equations in a matrix method, in a matrix form. Babylonians also studied matrices, but Chinese did much studies in them. And the Chinese matrix method is commonly known as today the Gaussian elimination method. Gaussian elimination method. This method can be used in the higher order. The theory of matrix was developed by mathematicians named Gottfried Leibniz. He first took out coefficients of linear equations, put them into matrix. Then Carl Gauss further developed the matrix theory in 1700 late. He added matrix multiplication, inverse, Gaussian elimination. So Gaussian elimination is a method to solve the system of equations with 3 or more variables. It involves getting most matrix numbers to 0, or also an identity matrix to convert the given matrix into identity matrix or 0 matrix. So this method is Gaussian elimination method. This comes in higher studies. This is done to elementary operation. This method is processed by elementary row operation or column operation. So this method is also actually in Chinese text. This method is mentioned in Chinese text. But Gauss rediscovered it. Next, Sylvester gave rectangular tables named the matrix. So that in Latin for whom in 1850. He also reinforced the theory with the process of finding determinant. Finally, a man, Arthur Kelly, a good friend to Sylvester, he came up to the many matrix contributions such as matrix multiplication, addition, subtraction and division. Is also further added to inverse theory. He gives precise definitions of discovered scalar multiplication of matrix with multiplying matrix by an integer. So this is the history of matrices. Now we'll discuss some of the applications in real life situations. Used in a real life applications, finance sectors, science, manufacturing, optimization, etc. to solve the linear system of equations. Matrices are mostly used to solve the linear system of equations. Delta Airlines used to linear programming that is based on the matrix computations to solve its flight scheduling problems. The problem is too much aircraft to 5 lakhs and fill seats with the paying passengers. They are reducing the operation cost. So this is to reduce the operation cost. So they use the matrix in Delta Airlines. Some of the applications in computer science. Among the most common tool in electrical engineering and computer science are rectangular grid. The number is known as matrices. The number is a matrix can be represented data, and they can also represent mathematical equations. In any time sense, engineering applications, multiplying matrices can give quick and good approximation of values. So these are the few applications of matrix in computer science. Now matrix in physics. The physics related applications, matrix are applied in the study of electrical circuits. To study the electrical circuits, the matrix are applied, the quantum mechanics and optics. To study these, they use the matrix electric circuits, quantum mechanics, and optics. So, in the calculation of battery power of outputs, resistor conversion of electrical energy into another useful energy. These matrices plays a major role in calculation to calculate the power of outputs, the conversion of electrical energy into another useful energies. They'll use the matrix, especially in solving problems using Kirchhoff's law of voltage and current. The matrix are essential part in the physics. So these are the few applications in matrix. So now we'll discuss what is matrix, what are the types of matrix, how to do multiplication, addition, subtraction, everything. So now we'll discuss the matrix. Definition of matrix is a system of mn numbers, that is by real number or complex numbers, arranged in a form of order, that is horizontal lines and vertical lines. The horizontal line is called row and vertical line is called column. So that is called matrix. So here that m by n, read as m by n. So m rows and n columns of this given matrix. So that representation is A11, A12, A13, so on A1j and so on A1n, A21, A22, A23 and so on A2n. Similarly, AM1, AM2, AM3, AMJ, so on AMN are the m rows and n columns matrix. So now this is the first row of matrix. This is the row R1. This is the second row. Horizontal lines is called rows. The vertical lines is called columns. Vertical lines. Now see the vertical lines. So these are the vertical lines. C1, C2, C3. These are the columns. C1, C2, C3, C, Ij, Cn. In these matrix, m rows and n columns. First number represent rows and n represent columns. It has m rows and n columns. So if they ask you to construct 2 by 2 matrix, means this is the form A11, A12, A21, A22. So 2 rows and 2 columns. So this is the 2 rows and this is the 2 columns. This is R1, R2, C1, C2. 2 rows and 2 columns of the given matrix. So that is 2 by 2 matrix. The general form of 2 by 2 matrix is A11, A12, A21, A22. If you take 3 by 3 matrix general form, A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is the order of general form of 3 by 3 matrix. Sorry. It is denoted by Aij, m by n matrix, m into n, m rows and n columns. For example, if a matrix has m rows, if a matrix has 3 rows, number of rows is 3, and number of columns is 2, then order can be written as 3 by 2. So total number of elements is 6. 3 2 is 6, the product of 3 into 2, 6. So here 3 represent row, number of rows, and 2 represent number of columns. Next model is, if a matrix has order is 3 by 4, the matrix of order is 3 by 4, then number of elements is number of elements is 12. If a matrix order is 3 by 4, the number of elements is 12. Another example is, if a matrix has 4 elements, the number of possible orders, then the number of possible orders equals to 2 into 2, 1 into 4, 4 into 1. So the number of possible orders is 3. 3 orders will get. Another example, if a matrix has 13 elements, then number of possible orders is 1 into 13, 13 into 1. So total how much will get? 2 orders will get. So this is the different orders, 1 into 13 and 13 by 1. 1 by 13 and 13 by 1. 2 orders. Total order pairs will get 2 order pairs. And one more example. If the order of the matrix is 8, then what are the possible orders? The possible orders are 1 by 8, 2 by 4, 4 by 2, 8 by 1. So total possible orders is total possible orders are 1, 2, 3, 4. 4 possible orders will get. That is 1 by 8, 2 by 4, 4 by 2, 8 by 1. So total possible orders is 8. Next we'll see the types of matrix. Rectangular matrix. If any matrix m rows and n columns is called rectangular matrix, means m rows, the both are not equal, m is not equals to n. So m is rows, n is columns. So m represent rows and n represent columns. This is row, n column. Example is A is equals to 1, 2, 3, 4, 5, 6. This is the matrix of rectangular matrix example. So it contains 2 rows and 3 columns, 2 by 3. Another example, if B is equals to 1, 2, 3, 4, 5, 6. So order is, number of rows is 3, number of columns is 2. So this order is 3 by 2. So this is also called as rectangular matrix. So number of rows and number of columns are different is there. That matrix is called rectangular matrix. Next is square matrix. Any n by n matrix is called square matrix of order n. So n rows square matrix. In case number of rows and number of columns are equal, so the number of rows and number of columns are equal, then the matrix is called square matrix. For example, A is equals to 1, 2, 3, 4 and X is equals to 1, 2, 3, 4, 5, 6, 1, 3, 7. So this is the 3 by 3 order. This is 2 by 2 order. This is square matrix. Number of rows and number of columns are equal, then we call it as square matrix. Now row matrix. If any matrix is the order is 1 by n, matrix is called row matrix, a row vector. So it has only one row. For example, A is equals to 1, 2, 3, 4. One row. How many columns are there? 1, 2, 3, 4 columns. So this is one row, this is columns. So 4 columns and 1 row. So 1 by 4. Order is 1 by 4. If x is equals to 1, 2, 3, then this order is 1 by 3, and y is equals to, y is a matrix 1, 2, 3, 4, 5. So the order of this matrix is 1 by 5. 1 by 5. So this matrix is called row matrix. It contains only one row and many columns with many columns. Next is column matrix. If a matrix m by 1 of order is known as column matrix or column vector, it has only one column. The matrix has only one column. So for example, A is equals to 1, 2, 3. So 3 rows and 1 column. So order is 3 by 1. And B is equals to 1, 2, 3, 4. So 4 rows and 1 column, 4 by 1. So the column matrix has only one column and many rows. With many rows is called column matrix. Horizontal matrix. A matrix in which the number of columns is more than the number of rows. Number of columns is more than the number of rows. For example, A is equals to 1, 2, 3. Columns is more than the number of rows. 4, 5, 6, 1, 3. So columns is, so order is, number of rows is 2 and columns is 4. Number of columns is more than the number of rows is called horizontal row. Vertical row. A matrix has only more than rows the number of columns. The number of rows more than the number of columns. For example, A is equals to 1, 2, 3, 4, 5, 6, 7, 8. So here 1, 2, 3, 4, 4 by 2. So this is vertical matrix. Now see the diagonal of a matrix. First we discuss the diagonal elements of a given matrix. In a matrix, elements A11, so Aij, where Aij equals to, Aij is said to be diagonal elements. I is equals to j, both I value and j value both are equal, like A11, A22, A33. These elements are called diagonal elements. A11, A22, Aia are called diagonal elements of a given matrix. Is also called as, this line is called diagonal elements. Principal diagonals. The elements are called principal diagonals. This is also known as leading diagonals or diagonals. So here diagonals are 2, 1, 0 is the principal diagonal elements. That is A11 is 2, A22 is 1, A33 is 0. These elements are called principal diagonal elements. Now discuss the diagonal matrix. A square matrix A is equals to Aij is said to be a diagonal matrix if Aij equals to 0, where I is not equals to j. Aij, A equals to Aij are equals to 0. I is not equals to j. I is not equals to j. So this is k, I is equals to j. So this is what A12 are different, I and j are both are different. This is 13, I and j are different. So this is what, these are the principal diagonals. That is A11, A22, A33. Except these elements, remaining all elements are equals to 0. That is called as diagonal matrix. The diagonals matrix also can be symbolized 1, 4, 7. This is the diagonalized matrix or diagonal matrix of order 3. Next, scalar matrix. A square matrix or a diagonal matrix is said to be a scalar matrix if its all the diagonal entries are equal, elements are equal, diagonal elements are equal. That is, A is equals to Aij by m by n matrix is said to be a scalar matrix. Aij equals to 0, Aij equals to alpha, alpha is the same number. For example, A11 is equals to A22 is equals to A33 when it is 3 by 3 or k something. These all elements are equal. So 2 0 0 0 2 0 0 0 2. This is the example of scalar matrix by order 3 by 3. So example is given 3 by 3, 1 plus I 1, 1 plus I 1 plus I. All the principal diagonal elements are same. All the principal diagonals are same. So this is order is 1 by 1, order 2 by 2, order 3 by 3. So non-diagonal elements are equals to 0. So the difference between scalar matrix and diagonal matrix is, in diagonal matrix, principal diagonals are different, non-diagonal elements are equals to 0. In scalar matrix, principal diagonals are same, also same, non-diagonal elements are equals to 0. In scalar matrix, principal diagonals are equal or same. In diagonal matrix, principal diagonal elements are different numbers and remaining all non-diagonal elements are equals to 0. Now identity matrix. A square matrix is said to be identity matrix of its diagonal elements are equals to unit. So and also 1. It is also known as unit matrix. A is equals to Aij, M by N is called identity matrix, where I is equals to, it is denoted by I is equals to Aij. 0 when I is not equals to j, 1 when I is equals to j. So it means A11, A22, these elements equals to 1, the rest of all elements are equals to 0. This is the order of 1 by 1, order of 2 by 2, 3 by 3. Let's see the principal diagonal elements are equal to 1. So this is called identity matrix or unit matrix. Identity matrix or unit matrix of order 2 by 2. This is the order of 2 by 2. This is order of 3 by 3. This is 2 by 2, 3 by 3 matrix of order. So 0 matrix. A matrix is said to be 0 matrix if each of its elements equals to 0, all the entries equals to 0, also called as null matrix, denoted by 0. So 0 is equals to number of rows, number of columns. All elements are equals to 0. This is 3 by 3, this order of this matrix is 2 by 3, this order is 3 by 3. Order of the matrix is 2 by 3 and order of the matrix is 3 by 3. In elements, all elements are equals to 0, that matrix is called 0 matrix. Next is triangular matrix. A square matrix A is equals to Aij is said to be upper triangular matrix. Upper triangular matrix, Ai is equals to 0, I is greater than j. I is greater than j. I is greater than j. So it means 2 1 3 1 3 2 like this. So below the diagonal, see, below the diagonals are 0, this that also called as upper triangle. Below the diagonal elements are g equals to 0. That matrix is called upper triangular matrix. Above the diagonal elements are equals to 0. That is called lower triangular matrix. We can remember easily that by comparing that above diagonal elements. So with the help of diagonal elements, below the diagonal elements all elements are equals to 0, then that is called upper triangular matrix. Above the diagonal elements, all elements are equals to 0, that is called lower triangular matrix. Here is I is greater than 0, I is greater than j and I is less than j. So this is the there are two types of triangular matrix, upper triangular, lower triangular matrix. Equality of matrix.